Like,
I like try and drag buttons onto my emulator and stuff, and it just doesn't happen. It'll like show a little itty bitty blue box in the upper left hand corner.
So what, like this XML, like Node XML?
Yes. Or no, activity main. Why can't I just copy and paste your activity main XML, and then I would get all the buttons and stuff to work in mine?
Well, I would think you should be able to.
That's what I would think, right?
So you went in here and you just copy all this, right?
Yeah, and I had to make a few changes because it has your name in it and stuff.
All right, I get it.
But other than that, it just says it just does not take it.
Well, let's try it. Let's create a new.
I don't know if it's because the versions are different. Like, do you have a different version, or?
I don't think that stuff's changed. So let's just call this test layout. Only lowercase letters. Okay, and doesn't matter what the root element is for that because we're going to be overwriting it. So do that. We'll go to text. So there, paste that in. Doesn't work on yours. What does it do?
It gives me a ton of errors and it won't open up the emulator at all.
Let's see. You shouldn't have to change this. Actually, it doesn't look like there should be anything you have to change. Oh, this, yeah.
Yeah, that part I had to change.
To match what yours is.
Yeah, but that, and I did that, and it like reduced it from 13 errors to 12 errors.
And you don't remember what the errors were?
They were all different. It has something to do with like it doesn't close properly, or it should be something different, or.
And you're positive you copied all of it?
Yes.
All right, let's try this. So you were grabbing it off of GitHub, so let's go that route. All right, so I chose a homework 5 branch, right?
Mm-hmm.
This guy. And then I went into app, source, resources, layout, activity main. Grab all that. Let's see if it's something with the format on GitHub. Like, in fact, I'm betting it's these double quotes. It seemed to. So are those errors?
Can I meet with you sometime so that you can take a look at it?
Yeah, I'm just trying to see if these are errors. So this is underlined in red. Then you would have had it under your main activity, and you would have just used test layout instead of activity main. So you don't see the errors, so you go to run.
I see them both times.
So I see this is underscored in red, but I don't see actual. Okay. So this is type stuff, XML junk after document element.
I don't know if I've ever seen that error.
Oh, I see an extra. That must have been me not must have not highlighted everything. Here, let's just make sure that's the case. Yeah, it looks like it's going to be happy, so yeah, we should look at it. Is that it? Is that it running? Kill it. Is there another one running somewhere? Alright, while this is rebooting, so homework assignment was to remove at index, added index? Is that right? Oh, make the buttons do their thing. I got you. That's right. Do we already write remove at index, added index? Or I say we're going to do that today? Do it today? Alright, so we did add remove front, add remove end, and then we made it show up and stuff, and we put the buttons on there last time, so now you're supposed to make the buttons work for add remove front, add remove end. Okay. Okay, well, so it looks like it's working for me, the XML thing. So we'll have to look and see where things are zigging or zagging. So here, let me just go back to activity main on this guy, just so shouldn't make a difference since they are duplicates. We'll still do that, and then I'll do that, and then I'll delete this. Delete. Okay. All right. So right now we have, well, right now I should be able to type in something here, like 24. And the idea is I click add front, it should actually put it here and update the list. Is that right? This says adding front, and I think I read in one of your posts is the other thing squish down.
Oh yeah. Like if you call display, nothing changes.
Yeah, so here's the scroll view. So this guy needs to. What row?
I moved up that one.
Okay, so this guy needs to get moved up there. All right. Yeah, so it's just a sizing thing. Oh, so did we already have 6 and 7 added to it by default? So if I do 24 and say add front. Okay, so it probably adds it, but it doesn't actually show up down here yet. Is that where we stopped? Okay, got it. Okay. So let's go in here and let's look at what's currently happening. Is this the minimize deal? Yep. Okay, and then I should be able to toggle that over there. All right, so here's all of our new buttons, and we made these guys global, so we have access to them in here. I think we wrote the on listener to determine which button was added. Oh, so right now we're not even really editing. We're just saying we're going to add it, right? We're not actually adding it to the list. All right, so If it was the add front button, we want to add front, so on and so forth. So these buttons should all function. Now we just need to get this guy talking to the actual linked list. So our display function here makes our linked list always show the next dude, right? It updates the thing, and that already works for our. So what we need to do here is we need to take our linked list. We need to make this guy a global variable. Private linked list LL. Then right here we can say LL is equal to that, and then that'll fill it up. And then just as an example here for add front, we would say LL.add front, this guy. What's this guy? This dot new value. What's he screaming about? This dot new value edit text dot get text comes out as something called editable. ToString. Alright, so that will add it to the front. This will add it to the end. This will remove front. Remove end, and then we'll update our display. So no matter which button we hit here, we're always going to tell our linked list to update. That'll update that display at the bottom. Otherwise, we just do whatever this guy says to do. Oh, I hope so. We'll see. We'll see if this works. What, you thought it was worse than that?
It was way worse than that.
Well, but you had the problem with the XML wasn't behaving.
Yeah, but still.
Alright. So there's this, so I should be able to, did it launch? Yeah, it launched. So I should be able to remove front. There's that. Should be able to do 14, add front, 14, add end, remove front, add front, 7, add end, add front, stuff like that. Alright, so so now those buttons seem to be doing what we want them to do. Alright, so next step is we would like to be able to remove something like here. Alright, well the issue is going to be is if we have a button like add an index or remove at index, for example, and I click that button, how do we want our interface to ask us about that? We have a couple of options, right? We can have it give us a little pop-up saying, tell us the bucket you want to remove. Alternatively, what we could do is I could maybe just click on this guy. And if I click on this guy, actually, hold on, is this is not an adapter view, right? This is just a scroll view. That's going to really make things more difficult, but that's okay. Well, here, let me just look at it out here. This guy is a, oh, he's a scroll view, okay. Interesting. Alright, so let's become even more fun. So when we display things, let's go in, let's go into our linked list. So as an idea here, we might like to click on this 7 and have something happen, or click on this 14 and have something happen. I wonder why I didn't do this as a list view. Oh, because could. Nah, we're going to roll with it this way, at least at first. So that means that each of these guys, what we're doing is we're adding these to our scroll view, right? So every single time we say to display, if we go into the display method for our linked list, go in here, here's our linked list. Here's our display. So what do? We tell our layout to remove all the stuff that's in it, all those labels that are in there. Well, all these nodes that are in there. And then for each of those nodes, we go ahead and, well, if we don't have a null, we go ahead and we grab our a view. So we grab a node. Oh, this is if it is null. If we have the empty list, then we're just going to create a view, have it say empty list, so on and so forth. Otherwise, we'll go ahead and tell each node to display itself, and we pass that node the layout. So if I'm a node, somebody's gonna ask me to display myself. I'm gonna get past the container in which I should display myself. I'm gonna create that layout and throw it into that container. So we'll look in node. That's where this happens. So this is from an individual node's perspective. He gets thrown the container that he should display himself within. He goes ahead and he inflates his own version of himself. So inflates a node layout. Right? Then he goes ahead and fills that node layout with this guy, with the text, and then he sets the text. Well, this gets the text field. This sets the text, and then we're adding to that layout this new subview. So that guy should just horizontally put it. So now what we need to do is we need to teach each of those guys Let's see if we can do it out here. So let's do this, then go into node. So here's our node. We just have a single text view in there. Do we have an on-click for a text view? We do, but does it work? Let's add a method here called textClicked. And then let's write that method inside of our node. Public void text clicked view v. Let's just do a system.out.println. Text was clicked. This dot payload. All right, let's see if those labels will respond to click events. Usually, well, at the very least, the label should not be clickable by default. We might be able to turn it on, but we might need to switch those to buttons. So let's go down this rabbit hole. So the idea here is that we'd like to click on this guy, and because when the node associated with this text view was created, he went ahead and he created his own on-click method. So when I click the 14, that particular node should respond to that 14, and it should work. That's the theory. So at the very least, this guy, well, the hope is this guy will print out text was clicked and then show a 14, as opposed to if I clicked on the next guy, it should show a 7. So let's run that. Otherwise, we might want to convert this guy over to a list adapter. Oh, well, the good news is it responded to a click. Could not find the method text clicked. Okay, so we might need to, let's try it the other way before we completely bail on this. So before we add this guy to our layout, we're going to do TF add let's see. Set Onclicklistener to be a new Onclicklistener, and then we'll paste that in there. But we don't have access to this. So rather than relying on the on-click thing out here in our node, we'll get rid of that guy. He wasn't able to automatically find it. So now what we'll do is on a per node basis, we're going to, for each text field we create, we're going to go ahead and set an on-click listener for that guy. So each individual text field will have his own local method here that will know how to, when the text was clicked. Let's see if it can find that. And then we might just do this as a list adapter instead. Okay, so we got text was clicked, the 6. Text was clicked, the 7. Okay, so that works. So we could respond to those. So now what we'd want to do is we want to have something pop up. So have a dialog window pop up as a response to that, asking what do we want to do? Do you want to remove or do you want to keep it there? Oh, well, do you want to, what would be options? We probably should just assume remove right now, right? That's the only thing we could do. If I click on it, I probably want to remove it. So with that in mind, that's a good point. Let's automatically just remove it for now, and then once we have it removing, then we can add an option. What do we, maybe you want to do something else. So add above, add below. I think that's a good idea. Okay, so since we're clicked it, and now we're able to respond to the click. So understand what we did here is rather than using the built-in on-click thing out in the layout, for every text view that we create for every one of our nodes, we create a local function here and specifically attach this function to that text field. So that's this function here called set Onclicklistener. So I know these things start looking a little bit intimidating, but what we're doing here is if we think this is a text field, we're saying, look, I'm going to give you a little walkie-talkie that you can use to respond to clicks. So I'm going to set your on-click listener. I want you to listen for clicks. And this is what I want you to do when a click happens. I want you to do whatever's in there. All right, so that's what's happening here. We are setting this text field's on-click listener. We're setting it equal to something. What are we setting equal to? A brand new on-click listener. This is associated with the view class. So reviewing from last semester, on-click listener, what kind of animal is this? So you've never seen it before, but what can you tell me? Is that a method or a field? Method, how do you know? Well, you would have view dot for fields as well. We know it's a method because of that guy. Parentheses, right? Okay. All methods have parameters. They might take 0 parameters, but they at least have a parameter list. Fields would not have that guy. Okay, so we know this guy must be a method. Now the question is this a class method or an instance method? And how do we know? Okay. Why do you think it's an instance method? Because I'm... Okay. See, that's... actually very interesting. at first we would look at this and say, well, the dude who's calling Onclicklistener is view. And since view has a capital V, we would suspect that guy's the name of a class, right? And since this guy's the name of a class and he's calling a function or a method, that means this method must be a static method because that's the way we would call that guy. Now, having said that, the new keyword indicates that we're probably dealing with an instance of something here. Okay, so noticing the new keyword didn't tell us that this guy was an instance method. This guy's a class method because of the way he's specifically getting called. But this method must return something special that we can then use. It must return an object, an instance of an object that we can then use with the new keyword. So this guy ultimately must be a constructor. And this guy is called a closure. So that's a function inside of the constructor there. So this one's actually a little bit weird. So if we go and look at view let's go and look at view in the Android documentation. We should find a static in front of this, that function name. So it's a class method, but we want to look at what he specifically returns so we can understand the rest of this. Let's go in the Android documentation. Bring up something. Well, fair enough, but I want to see it in the documentation so we can see it. Let's just do Android View class. That should take us there. All right. So we should have. Okay, so interesting. So we have this thing in here. We have nested classes. So within that that guy, we have a whole bunch of classes that live within it. And one of those is this dude called Onclicklistener. So in fact, this guy actually isn't a function directly. If we go to Onclicklistener and we look at the constructor for this, well, the Onclicklistener took no parameters, so this guy didn't specifically create a constructor. That's why we've passed it no parameters. Every class, if we don't explicitly define our own constructor for it, or since they didn't define a constructor for it, it's provided a no argument constructor that supports this syntax along with the new keyword. Okay, so this is actually a new kind of animal that we haven't necessarily seen before. This is not a function call. It was hiding as a function call. It looked like a function call, but there's two things that we realize in the world of programming that have parameter lists. That is functions, methods, whatever, and then constructors, right? Constructors will always have the new keyword before them. So we should have recognized that this guy was in fact a constructor from the new keyword being here, because that's what's always following this. So when we said view.onClickListener, because we saw the new keyword, we should have been able to identify this guy, and I didn't either, so this is not just on you. We should have been able to identify this guy as a class. This is a constructor, what this ultimately boils down to. It certainly looks like a static thing because we're calling it with the name of a class, but in fact this is this new kind of animal which is called an embedded class or a nested class. That's what they're calling it here in the documentation. That is, the view class has within it a whole bunch of other classes, little tiny subclasses that do something. So as we just saw there, this class doesn't do a whole lot. So this is a little tiny class that was created inside of the view class. So inside of view.java, we have another public class Onclicklistener, and that class has exactly one function in it. Okay, and it's an abstract function which says we have to implement this. We have to write that function ourselves. There isn't a pre-built one. That makes sense? So this could have certainly been implemented on the Android side as two completely separate classes. We could have had view.java, and then we could have had an Onclicklistener .java. It's two completely separate files. But we're not required to do that. We can have a single file with multiple classes inside of it. Okay? That's what they've done here because these are kind of mini classes. They don't have a whole lot going on in them. So the Onclicklistener class literally says, here's a method you must define. That's all I'm telling you. There's this method called onClick. So we have to write this guy. So what we're doing out here is we're saying, I want to construct a new one, an instance of the Onclicklistener class. So I'm using my view class to get to one of his nested classes, a class that lives inside of the view class. And I want to create an instance of that guy. So that's what we're doing right here with this new this. And then specifically, we are inlining the implementation for that instance right there because we are required to implement the onClick method because it's abstract, right? Remember the abstract keyword from last semester? Abstract means that you must implement this. An implementation, it's there for inheritance only. All right, so we have to implement this guy. So we're going to go ahead, and this syntax allows us to go ahead and create that implementation inline. So along with us creating our instance of this class, we're also defining that one method the class has. So this is kind of a convenience. This is evidence that this is like this tiny little mini class that we can kind of use on the fly. So we're creating a new instance of our Onclicklistener class. And this particular instance overrides the onClick method that we have to override, we have to create. So we have a new method called onClick, must look like this, and right now this guy just spits out text was clicked and then the payload. Now what's kind of interesting about this is historically I've always mentioned that I want to, I like to say this dot, right? And right now this is an error. What is the this keyword? So if we're connecting some of the stuff from last semester, if you had to define the this keyword, what would we say? Okay, well, I mean, it sounds like you kind of know what it means. So you didn't have the benefit of all my awesome definitions from last semester. But clearly the rest of the class that did is doing great with this answer, right? So what does the this keyword do? Points it to the most local definition. Most local definition of what? Okay.
Access to a private variable.
It will give us access to our private variable. It doesn't really tell me what this keyword does.
How it refers to itself.
From within itself. So this keyword is how an instance of a class refers to itself from within itself. Okay, so right now we are living inside of the node class. So if I say this, I'm referencing this particular node, this instance of node. So when I say this dot payload, I'm talking, if I'm a node, I'm talking about my payload, not that node over there's payload, my particular payload. Okay? Now the issue here is that I typically like putting this in front of it so I omit spelling errors, even though it's not required. But notice it's complaining right now. And this is because things are a little bit different in this scenario. This method actually lives inside of an instance of what? An Onclicklistener. So when I say this right here, like we just defined, this is how an object refers to itself from within itself. So if I'm living inside of this onClick method, which is a local method to this instance of Onclicklistener, this keyword references that Onclicklistener. And Onclicklisteners, as we're seeing from the little red highlighting, they don't have a variable called payload. That make sense? So in this particular case, this is actually incorrect. I mean, I can say this all day long, but when I say this dot, I'm referencing this instance of Onclicklistener. So I'm only going to have access to stuff that he provides. And payload isn't one of those things. Make sense? All right, so this is one of those things where at a glance, you think it's one thing. But upon further inspection, it's acting a little bit different. This is one of the nice things about, well, it's kind of one of the things that as a class right now, we get to benefit from as well as struggle with. Because when we start looking at stuff in the Android ecosystem, we're seeing kind of these constructs that we're not used to seeing when we were just dancing with kind of normal Java, right? But what this is doing is it's kind of training us to look at things a little bit closer. Now, having said that, if I take this dot off, it works. Okay, so now this starts going to something she said, talking about variables, they resolve to their most local definition, right? Every variable always resolves to its most local definition. When we put this in front of it, we're kind of forcing it not to look locally, but instead look to the fields of this instance of the class. Okay, well, we saw that this dot didn't work here, and it didn't work for a good reason, because an instance of Onclicklistener must not have a payload. Okay, we told it exactly where to look, and there was nothing there that matched the description of what we asked it to look for. So now we're just saying payload. So we're relying on Java to resolve this variable to its most local definition. So first of all, it's going to look here inside of this local scope. That's our most local scope inside of the onClick method here. Do we see a variable defined in here called payload? No. We do not see a variable. I'm hoping this is just, is 10:43 that early? I mean, maybe for emo, he was here till 10 o'clock at night. Then he probably went and played video games. You were sleeping during class, weren't you?
Trying not to.
We did a lot of stuff last night, didn't we?
did do stuff.
Yeah, man. We learned a whole mean stack. It's exciting stuff. You're ready for a job interview right now. All in one class period. All right, so we're looking in this local scope. So scope is kind of where we have access to a variable. So the most local place we can search for a variable called payload is inside what I have highlighted there. Okay, that's the function we're currently living in. Function method. Because I've been doing a lot of Swift lately, they call them functions. So I'm going to flip-flop between those. They're the same thing. They're synonyms. So this is our onClick function. We're first going to look in here. We don't see a definition for a variable called payload. So far, not found. So we're going to bounce up to the next local scope. What's the next local scope outside of this onClick method? Pretty related to what we've been talking about today. This onClick method lives within an instance of Onclicklistener, right? So the next most local scope is going to be the environment provided by Onclicklistener. So the next local scope is going to be Onclicklistener's fields. Right? Does that make sense? Okay, and as we saw when we tried to put this dot in front of payload, there isn't a payload there either. Right? So it looked up one level and said no payload there. Now, typically we would say that we're done, or if we're in some sort of chain of inheritance. So for instance, an Onclicklistener might inherit from another class. In this case, we just looked at the documentation. It doesn't do that. It's just a normal, well, actually, it does do that. All classes inherit from object. So after it checks Onclicklistener, it'll then check the object class to see if it has a payload. It doesn't. All right? So now we're back and saying, okay, well, I didn't find it locally. I didn't find it as a field of the class that I live within. I didn't find it as a field in the class that he lives within. Usually we would be done checking. But because of the way we've implemented this, because we've set the Onclicklistener inside of another scope, we have another place to look. Actually, we have several other places to look. We can look for a local variable inside of this display method. That would be the next most local scope, right? then we can jump up to the fields associated with this class, which is node. Right, so we have two brand new scopes that we typically wouldn't have access to through the normal inheritance channel because we're dealing with this guy as an instance of a class within a class. Make sense? So at the end of the day, it will ultimately find payload where we tried to tell it to find it. When we said this.payload, we meant to look in nodes fields. But what we actually said was look in Onclicklisteners fields, because we are inside of one of those classes. Make sense? That's kind of that definition of the this keyword. This is how an object refers to itself from within itself. In this case, we happen to be within an instance of Onclicklistener, even though that was a little bit of a gray area for us for a second. All right, so we can access the payload here. Now, our goal would be to go ahead and remove that guy from the view he's in. Well, this is the number we want to remove. But what we actually want to do is we actually want to remove this text field that holds that number. That's what we actually want to get rid of, correct? So we need to have access to that text field. It just so happens that we should have access to that text field in here. So we're going to say tf dot. So here's that text field because that's in scope, right? Let's see, remove. Actually, we might need to do this. We might need to do layout dot remove view tf. Let's see, is it not? Variable layout is accessed from within there and needs to be declared final. Okay, so that's probably not. So this is a special rule here that layout would need to be declared as a final variable, that it can't be changed because of kind of the way that we are provided access to that scope. So the easiest thing for us to do would be give ourselves access to those two things up here. So here's our layout, here's our value label. So we must be setting those somewhere. Well, we define them up there, but we never use them. Value label and layout. Well, let's go ahead and use them. So what we're going to do here is we're going to say this dot layout is equal to layout. And then instead of tf here, we're going to say this dot value label is equal to the text view of that. So we'll set the text in our value label. We'll set our value labels on Onclicklistener. And then we can say layout dot, it won't be this dot value label, it'll just be value label. Oh, it's going to get confused with that guy. This dot the layout, and then we should be able to say the layout here. It was in conflict between this guy, which was not a final variable. Final variables are variables that can't have their value changed, so it effectively becomes a constant. So I just renamed the global one to not match this name. So when this guy went searching, he would find the one that's the field of node, the layout, and then we're removing the value label from that. So the hope is when we click on something, it will remove from that layout but we'll have to, one concern, we also have to remove it from the linked list, but let's just see if it'll visually disappear from our screen. The concern is will the guy below it suck up? Or will that scroll view, if it's already been laid out on the screen, will there just be a gap there? Either one is okay for right now, but the question is what will actually happen visually to us on the screen. So let's look at that. All right, so here let's do a 14 add front, 14 add end. Let's click on the 6. Oh, did he not actually? What's this? We can tell the layout to refresh itself. So we can say the layout dot refresh drawable state. And the real way to do this is probably this. We don't actually have to remove the label here. Is our linked list? Okay, so we need to go up a level. So right now, so let's do this maybe in a relatively intelligent way, I guess. We could probably make this work. Let's just try it real quick. So we'll do the layout refresh drawable state, and the hope is that notices it has one less view that hasn't already been thrown on the screen. And now let's see that guy done. So he'll reload his subviews, because we did remove the view from our layout, but it didn't update what we were visually seeing. Yeah, that guy's still there. We could probably cheat this a little bit. Instead of removing it, we can probably do something like value label dot is it visible? Set visible? They have a looks like we can set it to gone. So value label dot set visibility to view dot well, just for the sake of argument here, I'm going to throw a 2 in there. Pretty confident that's probably what that guy is. View dot invisible. Okay, there we go. That's what I was looking for. View dot invisible, which is a constant for an integer. So we're going to set the visibility of that label to invisible. This should definitely have a gap in there because it's still there. We just can't see it, but hopefully it will disappear from our site. Then we're going to try view.gone and see if that actually does the magic of making it gone. And then we're going to do this in a better way. We're going to use a singleton to actually store our linked list. Because what we'll do is we'll ask our linked list to remove something from the list. And then we'll go ahead and tell the list to redraw itself, which should just do this whole thing from scratch. So I click that, yeah, now he disappeared. Click that, now he disappeared. They're still there. You know, we just can't see them. If I do 14 and I do add end, oh, it refreshed it, so now his he got reloaded, which set the visibility back. So now let's try it with gone and see if that actually dumps it. Because remember, we're setting, the reason they came back when we added the thing is we asked our linked list to redisplay, right? And that emptied our that layout and then created brand new labels to throw in there that did not have the visibility set to invisible. So let's get rid of the 6. Okay, that seemed to move. Well, it didn't seem, it did move. So now if I do 14 add front, he's still there. So gone physically makes the view go away, but it, oh wait, no, we might be okay here. I never actually removed it from my linked list, so it made sense it came back. So I think he did disappear. So that did accomplish what we wanted it to accomplish. But we still now need to be able to remove something from our list. Now, we have a couple of interesting things we have to do here. Historically, what we talked about last time was this idea that we might want to remove at index or add at index, right? Well, the issue here is that if I've clicked on this guy right here, he is a visual representation of an instance of node, correct? This happens to be a text view, just a label, but he's the label that is the interface. You know, if a node object, which is kind of invisible to the human eye, was holding up a poster in front of him and saying, "This is me," I clicked on that poster. Behind the scenes there, the guy's like, "Okay, I'm supposed to go away." But what he's doing right now is he's doing this little magic trick where he's like, "Okay," and he's just disappearing from the view, right? Kind of scrunching up in a little ball somewhere. He's still in the list though. All right. We need to actually get it. We're getting. I see some smiles or something. We're waking up a little bit. All right. So now we need to actually remove him from the linked list. The problem is we don't know what position this guy was in the linked list. We might be able to figure that out. We can probably maybe pass integers into our nodes so our nodes kind of keep track of where they live in the list. But from this node's perspective, the guy that's holding up the poster, he was like, "Okay, you clicked on me. I'm supposed to leave the linked list. Now I'm going to, assuming we put the linked list up in a singleton so we can tell him we're going away, I'm going to say, hey, linked list, I need you to remove me." So we're not telling the linked list to remove something from bucket 4 or from the front or from the end. We're telling it, I am a node, dump me from the list. Make sense? So now we need to build a function into our linked list to first find a node find the position of a node given a node. That makes sense? All right. A node's just a pointer. So what we're doing is we're going to traverse our linked list until we finally find a node whose memory address is equal to the node that wants to get out of there. All right. So let's find the index first. So we're going to do a couple of things. We're going to first move our linked list up into a singleton. That way we have access to it from within node. Right now, we have access to our linked list anywhere inside of main activity because we moved it up here. Right? Go ahead.
Once you find the node in the list, do you even need to know what index you're at?
Well, you don't necessarily need to know what index you're at, but you're probably going to need to know, I mean, the answer is no. We're going to start off by getting the index, just to proving and find it. But effectively, we just need to get there so we can disconnect ourselves, which is going to ultimately mean we need to come up to the guy right before me. But you're right. Once we can position ourselves at the correct node, disconnecting it shouldn't require an index. But the index function we're going to write, at the very least, will tell us that, yes, we're able to find this guy, and it says he was at bucket 3, and that seems to line up with what I'm seeing, so things seem okay, right? All right. So what we need to do is we're going to go ahead and create in our list core, we're going to put that linked list up there. So this is our singleton. So we're going to create a static linked list called L, or called LL. And this is inside of list core. So now back here in main activity, we'll get rid of this guy here. We'll no longer have a local linked list there. So now when we define our linked list, we're actually setting the linked list that lives inside of list core. So now all of these guys now need to reference that linked list that's in the singleton. But this also means that now our node class, every instance of node, has access to the list in which he lives. Here, we don't need this anymore. That was just our testing thing, right? Similarly, these were all testing as well. We're not going to remove front. We're not going to display. Let's just do that. We'll fill it with 6, 7, 8, display it. So we'll just start with 6, 7, 8 as our starting point for our list. Eventually, we'll probably empty it out and let us build our list ourselves, but we'll give us something to work with initially. Okay. So here's all those button click stuff. So all those now need to access the singleton linked list. So same exact variable, he just lives in a new place, so we need to tell him where we can find it. All right. So now what we want to do is we want to write a function inside of linked list that will return for us the index of the element in our linked list given the node. Okay? This is going to be helpful for the problem we're solving here. Problem we're solving is the problem of, I have a node, the guy behind the poster, I'm a node. I can tell you my memory address, so I'm going to ask the global linked list to go find me. And he's going to prove he was able to find me by returning the integer position I was in the list. So inside of linked list, we're going to go ahead and we're going to write a function, public int find node n. Let's see, find node index. They'll take in a node n. All right, and this guy needs to walk through our, actually, if we want to, we're going to match this to something we're familiar with from string. This is index of. Remember from the string class, index of takes in a character, and returns the index of that character, or -1 if it was not found. We'll have this guy work the same way. Okay, so we just happen to name him in something, a name that's familiar to us. So if head is equal to null, return -1. Fair enough. Not found. Here's a -1. Otherwise, we have some looking to do. So just like we did before, to traverse our list, we need to set a node pointer that's going to start at the head because we're not going to modify head. And we want to keep traversing our list until we don't have any other place to go. And we need to keep track of where we are, current pos. So right now we're at pos 0. And if we run into a node that's equal to n, the node we're looking for, then we can return the current value of pos. All right. So we'll set int pos is equal to 0. Then we're going to say node, cur node is equal to head. Then we're going to say while curnode dot, let's see, this guy's a node, get next node is not equal to null. So as long as this guy is not equal to null, we should be able to take another step. We'll go ahead and take the next step, but we're going to ask the question first. Actually, we probably want to do let's ask the question here, and then we'll wrap it with something. So the question we want to ask is, if curnode is equal to n, if we're looking at the node that matches the node we're interested in, we're going to return pos. Else, we want to increment the value of pos. Now, if I'm in this else, I know that there's at least one element in here, right? So I know that I can check this at least one time. So what I can do here is I can wrap this inside of a do loop. Do all of this. Check to see if it matches. If it does, then we'll go ahead and return the pos. Otherwise, pos becomes one bigger than it used to be. Then we need to set curnode to be the next guy. So we'll say if curnode.getNextNode is not equal to null, we'll say curnode is equal to curnode.getNextNode. And we're going to keep doing all this while curnode.getNextNode is not equal to null. So this is a little redundant. We're already asking that question here. That way we don't accidentally try to set, or grab a, well actually, no, we're okay here. So if we know curnode's a real thing, get next node, we can just do this. If we have at least one guy, we'll set pos equal to 0. We'll start curnode off at head. Then we're going to do this at least once. We're going to ask the question, is curnode equal to n? If it is, we'll return pos. 0. Found it in the very first bucket. Otherwise, pos becomes 1. And we'll go ahead and set curnode equal to his own next node. This guy might return a null. That's okay. We know that curnode's a real thing. Otherwise, we wouldn't be in here. So when we ask curnode for his next node, it might give us a null because curnode might not actually have a next node. So we're going to keep doing this over and over again as long as the current value of curnode is not null. As long as I actually have a curnode, we'll go ahead and scroll back up, go right here and ask, is the next version of curnode equal to n? Is the current version of curnode equal to n? If it is, we'll return pos, which will be 1 in this case. Otherwise, 1 becomes 2. Curnode equals his own next node, which may or may not be null, so on and so forth. That make sense? And then if we're in here, we would return -1 if we never returned anything, didn't find it. So we could modify this a little bit. We can say, well, if this dot head is not equal to null, let's do all this stuff. So as long as there's something in there, let's check. And then we'll just do a catch-all, return -1 down here at the bottom. So if I have stuff in the list, let's go ahead and see if we can find the node we're looking for. If for some reason I get here, either I traversed the entire list and didn't find it, or head was equal to null and I just drop right here, I'm going to return -1. Make sense? So same logic, either one would have gotten the job done. This one seems to be fairly smooth. So now we know the index, well, we should be able to ask the linked list for the index of ourselves. All right, so let's go back into Node. So now we're setting a dude's visibility to nothing, but let's go ahead and do this. Let's do system.out .println position is equal to, and what's called list core .ll.index of So we have an issue here. I am inside of the onclick function. The onclick function lives within an instance of Onclicklistener. I would like to pass list core LL myself. So the index of method, I need to pass him myself. I'm a node, but currently this references what? This references this Onclicklistener, the instance of Onclicklistener. So we're in here. I can ask this node what his payload is, but he doesn't know about himself. Right now, this node has no way of letting index of know about himself. He can kind of reach at his pieces. I can get my payload, I can get my next node, but I have no way of getting at myself. The way a object refers to itself within itself is with the this keyword. Unfortunately, in this context where I'm sitting right now in the code, this means something else. The this keyword references the instance of Onclicklistener that I'm in. It's kind of problematic. So how can we give ourselves programmatic access to this node inside of this context without using the this keyword? Do we maybe have to invent an alternative to the this keyword? If you had to describe the this keyword for a node, what kind of variable is it? So if I'm in the node, if I'm in an instance of node and I'm not inside of this sub-instance of Onclicklistener, what kind of value is this? Say this again? It is a pointer, okay? Specifically, what kind of pointer? If you were looking at the actual variable definition for this, what would it look like? Variable definitions are always type, followed by variable name, equals value. What would the type in the variable name be? We already know the variable name. It's called this, right? What's the type of this? I guess as all of you are probably overthinking this. You said it's a pointer. Specifically, this is a pointer to a what? It's a pointer to a node, right? So wouldn't this be defined as node this equals something? That's what it is. So couldn't I say final node myself is equal to this? It's a synonym for this right now, right? And we did this little final thing. So rather than throwing it up top, because anywhere else inside of this application, anywhere else inside of Node, we would have access to this. So we don't need to have multiple ways of talking to ourselves. Because then you get the whole weird third person thing. You're walking down the hall and says, well, Mike wants to turn left. Even though in my head it's I want to turn left. Get it? That's just weird. Okay. But we do need to have access to it right here. So now, inside of our code right here, where I'm trying to call the index of function, I can't say this like I want to, because this doesn't reference a node. This references an instance of Onclicklistener. But I can say myself. That make sense? So I've given myself a walkie-talkie to talk to myself inside of this new world that I just jumped into here. Okay, so once I jump into a new object's context, so that's what context is. When we talk about context in any sort of programming, but in Android they throw that word around quite a bit. It's initially intimidating. Context is one of those, I don't know, abstract words. You know what I mean? But all we're saying is if I were to look around where I am, where am I? That's my context. Right now, the context is that we're in S120. Okay? If we walk out in the hall there, we have a new context. Now we're in the hallway. Okay? If we go into the cafeteria, we have a new context. We're in the cafeteria. Right now, my context is I am living inside of an instance of Onclicklistener. But I need to have access. I've lost myself, right? As soon as I dove into this instance of Onclicklistener, I've lost the ability to say I. When I walk out of this room and I'm in that hallway, I can no longer say, I want to go to the cafeteria. For some reason, I can't talk to myself anymore. So I'm going to need to give myself this little reminder. Okay, we have short-term memory loss. Is the punchline here. So this is where our reminder comes in. So we created a variable, a final variable that just says, I promise this guy will not change. And we're just going to go ahead and set it to this. So we have access to that memory address that is us. Okay? So inside here, even though this no longer refers to me, myself does. And we're going to go ahead and ask our linked list that lives inside the singleton to go through and find myself in there and hopefully tell me where my position is. All right. So let's run this. So this is 0, 1, 2. So if I click on this, it should print out 1. There's position 1. If I click on this, it should also find, well, actually, if I click on this, it should currently be position 2. Because we haven't actually physically removed it from the list. We've just kind of hidden it from sight. So this should be a 2. And this should be a 0. And now if I add some, let's do a 14, add front, and add end, and add end, and add end, and add end. So this is 0, 1, 2, 3, 4, 5, 6. Let's remove 6. He found that guy at 6. Make sense? All right. So now we're able to find a guy. So what we want to do here is right now we hide this text label and prove that we can find myself in the linked list. For our homework, update this to remove myself from the linked list and then ask the list to display itself, which should update the entire view. That is to say, we will no longer need to hide ourselves. Does that make sense? If we can remove ourselves from the list and then tell the list to display itself, we'll be gone by definition. Right? We won't need to do this whole gone thing anymore. All right, makes sense what I'm asking you to do? Okay, so you had mentioned that even though I created a new branch, when you checked it checked out the old thing, or did it have the most recent code?
When you can't for
Okay.
the full repository. So what I did is I just downloaded the zip, put it where I wanted, and then instead of doing the full checkout from version control, you just go in and say build from Gradle.
Okay, so what's the best way for me to update this? Do I just push it and you guys just find the most recent? Or do I actually create the separate branch? It sounds like creating the separate branch, other than seeing our new starting point, didn't necessarily make a difference.
It doesn't really, it does make a difference, but I mean, the branch is still useful, I guess.
Oh, from a starting point perspective.
Just to see
All right, so I'll create a new branch for homework 6, and I'll put homework 6 up there. But the idea is that when you pull it, you aren't able to pull a specific branch. You should be able to, but
I mean, I don't
at the very least, you haven't seen how to do that.
Right.
Okay, I got you.
That was the problem that I had with mine too, because when I put it on there, it wasn't until I dug through the code, because it was calling the add remove end, and then when I looked through everything, it wasn't even there, so it must have pulled from the master.
Okay. Well, I would think that it would still. So maybe that's what I need to do. Maybe I need to create the branch for homework 6 and then make that the new master.
that might.
That way, the default pull will pull the most recent, but I've also dictated this was the starting point for homework 6 from a comment perspective. Okay, I'll play with that. I'll play with that a little bit today, and I'll put this up. Let me get this uploading.